This video is to demonstrate the execution, testing, and discussion of the distance vector routing algorithm lab. Here we have the code. This is the original code. This is just all information that we don't really have to know. It just essentially creates the events and the packets, and actually has the layer 2 thing, sends out the costs, makes the min costs, everything like that. Where the actual information that has to be discussed is in the nodes. So we have node 0, node 1, node 2, node 3. So here we have node 0. It's very similar to node 1. As you can see, the difference is from all the nodes is just this number, and these are different. But in this case, I'm going to go over the code, I guess. So here we have the function prototypes and the external variables. Those are created. We have the constant mi is equal to 0. So in the other cases, mi is different, as I said. We have 0 to y and all the values. It's an array. 0 to itself is loop back. 0 to 1 is 1. 0 to 2 is 3. So here we can see where we have the structure the distance table is actually created. And then here's the initialization. So we're looping through. We're saying into the distance table, the cost from mi to y equal to the known cost to y from mi. Then we're going through and we're saying for all y, if it's not sending to itself and it can't send to a not connected packet, create a packet and send it out to that. So anything that's connected to that's not itself. So now we have the update function. So this happens whenever the node is initialized. Here we have an update function. So we're creating a variable v, and it's the source from which the packet is received. So it's a neighbor that is sending something to x. So for all y, the cost from v to y is equal to the minimum cost to y that's inside the received packet. So this is information that's inside the received packet. So next, we're going to set the minimum from mi to y through v to a huge number, 999. We're going to create changed equals false. We're going to now loop through all y again. So from x to v, the costs are mi to v. For v to y, the costs are v to y. So if y is not mi, if it's connected and known, so greater than 0 because not connected is -1, unknown is -2. If the combined path, so if from x to v, then v to y is less than x to y, or this is a new path, so originally this was not connected, then we want to update the table because this would mean it's shorter or it's a new route. So we're going to say the costs from v to y are equal to x to v, v to y. We're going to make it changed equals true, and we're going to output that the node found a better way. So now if it's changed, it has to update all the neighbors to the new changes. So we create a packet, we send it to all y, not to itself, not to not connected ones, create the packet and send it out. This is the same as the other one. And then we have the other print functions here, and that is the code. It's all the same for this except for ones in there. That is the code.